Hi guys, we're going to do an application of trig functions involving rotation. So here, I apologize for how poorly this is written, but I'll explain it to you. Here we have a Ferris wheel with diameter 30 meters, and we're going to graph the path of a rider starting at the bottom of the Ferris wheel and rotating counterclockwise. Now our goal is to graph the vertical displacement from the ground if the Ferris wheel is propped up 2 meters from the ground. So the first thing I like to do in these questions is kind of just create a little picture for myself. And the picture will be of our Ferris wheel. Okay, so let's say this is our wheel here. Actually, hold on, sorry, 1 second. Okay, here's our wheel. And basically here's some heights that we're going to reach. We're going to reach a minimum height, a maximum height, and a middle height. So the minimum height of a rider would be 2 meters above the ground. Okay, a maximum height of the rider would be the 30 meters that the diameter of the Ferris wheel is, plus this extra 2 meters from the ground. So the max height will be at 32 meters. Now the radius of this circle is 15. So if I go from the minimum 2 and up 15, I should hit the middle point of our graph, which we know is also our C value, which will be 17 meters. Okay, so here we go. We're going to graph this kind of step by step on our graph on the next page. We're also going to create an equation for this graph, just because. So the first thing that I'm going to do is, if I can create an equation for this, there's two ways that we could solve this. We could solve it by doing transformations, or we could solve it just by kind of tracking the path of the rider around this Ferris wheel here. So I can figure out amplitude if I have radius, which we said was 15, and that's also the a value of my function. Okay, so 15. Vertical displacement we usually use as a sine function, but you can also do it as a cosine function as well if you'd like. Sine, I know that the k value of this is 1 because it takes 360 degrees for a rider to get around the Ferris wheel, so that means that my k value must be 1. Okay, they're also starting at the bottom, so that means that the shift is going to be 90 degrees to the right. Okay, and my C value shift is just this middle value, so it's 17. Okay, so there's my equation. You could also get the equation at the end if you're asked for it, if you didn't quite understand exactly how I got all of those values. And we'll kind of look at the graph and see as well. Okay, so we're going to graph the path of this rider for one rotation, just tracking how high they are above the ground. And it's important to know that wherever you start is always considered that you've traveled 0 degrees, right? Because if you're just getting on the Ferris wheel at this point, you haven't really traveled at all. So right now we have traveled 0 degrees, and we're at our minimum height of 2 meters at this point. So I'm going to come over here and I'm going to graph 0 and 2. It'll be right below 2.5. There we go, 0, 2. Excuse me. Okay, the next place that we're going to rotate, the question tells us we're rotating counterclockwise, is up to this point right here. And at that point, we've now rotated 90 degrees. So we're at a height of 17 meters at a rotation of 17. So 90, 17. Right about there. Okay, going back, we're going to rotate up to the next important point, which would be the maximum. And so far we have rotated 180 degrees. So 32 at 180. So 180, 32, be about there. Okay, next important point. Down to, again, this was 17 meters. This whole line is 17 meters at 270 degrees, so 270 and back down to 17, and then all the way back around to our starting point, which is now also a full 360. So we said we started at a height of 2 meters, right? So it's going to be 360 and 2 again. That's one full rotation of our rider, so we can just, this isn't going to be great, but let me try that one more time. Here we go. There we go. And we could continue going further if we wanted to. Okay, but that's just one cycle graphing the path. So this is degrees, and this is height above the ground. Okay, and there you have it. Oh, and I also said that we were going to take a look at our graph here. So remember, when we talked about these functions, we talked about the c-value line, which we know to be at 17. And this midline, or the c-value line, tells us exactly where our sine function starts, which is 90 to the right. Okay, so since we can see that our midline, rising midline point starts at 17, we can see that our sine value, our d value for sine, is 90 to the right, and that's why we put this 90 value here. Okay, we can also see that the center of our graph is at 17, which means that that's our c value, and we can count the amplitude if we want. It goes from 2 to 32. So 32 minus 2 is 30, divided by 2 is 15. So there you have it.